My name is David Vacca, and I'm a software engineer working in the React Native team at Facebook. As Mike just mentioned, I'm a native Android developer, and that's why I mostly work in the Android side of the framework. In this presentation, I'm going to be sharing what is the current state of React Native inside Facebook. Because we believe that for a long period of time, there was some misunderstanding about the state of React Native inside the company. Many people have been wondering if Facebook really uses React Native, and how do we use it? That's why, a few months ago, Sophie from the React core team has published an update about the state of React Native inside the company. As a summary, she described that React Native is being used in many apps inside the company. Let's see some examples. First, of course, we need to mention Ads Manager. Ads Manager was the first app built in React Native ever. This is how React Native started. But to mention some more examples, the Analytics app and the Oculus Companion app are also brand new apps that were built in React Native. And these apps were actually released earlier this year. React Native is also integrated as part of existing native apps. For example, some screens of Instagram are built with React Native. Of course, we need to mention the Facebook app. The Facebook app is our major app, and there are several screens of the Facebook app that are built in React Native. We can mention crisis responses, blood donations, and privacy settings. But there is one special app that is called Marketplace. Marketplace is part of the main tabs of the Facebook app, and it's one of the maybe the most complex app, React Native app that we have inside Facebook. Marketplace is also being used by more than 800 million users, and it has more than 100 of screens. So it's a very important feature of Facebook. As part of her post, Sophie also described that the React Native team is working on other efforts to improve the framework. During the second half of the year, we're actually working in two major efforts. First, we are working on making React Native even faster. As we just saw, Marketplace is part of the main tabs of the Facebook app, and it's being used by more than 800 million users. So we need to ensure that the quality and the performance of Marketplace is as good as any other tab in the Facebook app. We need to be sure that the app is consistent. So in this effort, we are working to improve the time that it takes to load a React Native screen for the first time. We call this TTI, or time to interact. Everybody knows that loading a React Native screen involves starting the JSVM, loading the JS bundle, initializing view managers, native modules, getting data from the server, and so on. And each of these steps actually takes time. So part of the team is working on optimizing each of these steps to make sure that loading a React Native screen is as fast as loading a pure native screen. It's important to know that all of these improvements are going to be shared with the open source community, so you will get them for free. And I want to stop a little bit here. The React Native team has been working on performance for a while, and we have made a lot of progress. We believe that some of these optimizations are actually not being used by the open source community when actually the code is there, but we didn't make a good job sharing about each of these optimizations and sharing how to enable these optimizations. So we are also going to try to document more and share about how to enable the current optimizations that are already in the open source repository, so you can start using them. The other part of the team is working to enable new features in the framework. And in order to implement these new capabilities, we actually require to work on a major refactor of the core of React Native. And in the rest of the talk, I'm going to be sharing what are these capabilities that we want to enable, and an overview of the new architecture. But to understand the new architecture, first we need to understand the current one. So we are going to start with a little bit of background. How do we go from the code on the left to the screen on the right? As a summary, we have 3 threads. I'm going to go a little bit deeper into the native side. But we have 3 threads: the main thread, the shadow thread, and the JS thread. The main thread is a thread that is used by the platform to draw in the UI. Everything in the UI actually runs in the main thread. On the other side, we have the JS thread. The JS thread is where React actually runs. This is where the virtual DOM is managed and created by React. And in the middle, we have the shadow thread. The shadow thread is responsible for managing the shadow tree. The shadow tree represents the JS view hierarchy on the native side. In other words, we have the virtual DOM that is on the JS thread. And on the native side, we have a copy of this virtual DOM that is managed by the shadow thread. And we actually require these 3 in order to calculate the layout of the JS view hierarchy in the native side. So whenever native wants to render a new React native screen, it notifies React to start a new JS application. React will process this operation and it will create the JS view hierarchy in the JS thread. So now we have a new tree that is managed on the JS thread. We can say this is the virtual DOM. Every time that there is an update, JavaScript will notify back to the shadow thread about this update in the tree. So the shadow thread will create the shadow tree in the native side. It will measure the layout and it will queue the creation of the native views in the main thread. Finally, the main thread will process the creation of the views and it will mount the views on the screen. You probably noticed that I mentioned queuing. Well, the thing is, like, every time that a thread wants to execute something on another thread, it actually queues an operation into a queue. And all this communication is always asynchronous. Now, let's say that we want to change one of the views. For example, one of the JS views changes its background color. You can see that one of the nodes in the right side changed from a circle to a square. This is actually representing an update in one of the views. Well, React will process the update of the background color, and it will notify the native side that there was a change in one of the nodes of the tree, queuing an operation in the shadow thread to update the native tree. After the shadow tree is updated, this operation will reach the main thread, and it will update the new background color in the native view. So what's the problem with this approach? Well, again, all the communication between the threads is asynchronous, and rendering and processing updates asynchronous was one of the pillars of the current implementation. This actually allowed the framework to improve user experience, because we never block the UI thread. We basically process every single update in a background thread, that is the shadow thread, and then we move all the operations to the main thread, and we render the views. But using an architecture that only allows asynchronous execution, it's becoming a limitation. So what are the limitations? One of the limitations is that sometimes there are some cases when we actually want to process a JavaScript update and render synchronously. For example, for some specific gestures, we might want to run them synchronously in the main thread and improve user experience. Instead of like going from one thread to the other, we run everything in one thread. Also, with the current architecture, the computation of the layout must always run on the shadow thread. This brings a limitation when we want to integrate React Native inside a native surface that is not controlled by the framework. Let's see an example. This screen is divided in 3 sections. The first section is a set of native views. This can be a profile picture, a title, and a subtitle. Now, the second section is the important one. The second section is a React Native root view. And the important part is that the size of this native view is going to be determined by the size of the content of the React Native views that are going to be run inside this view. Finally, the third section is another set of native views that are also managed by native. So what happens when we want to render this screen for the first time? In the first render, the user will see that the native views are being rendered correctly, with the right size and the right content. But the React Native content will still probably be empty during the first render. So the size of the React root view will probably be 0, or it will display just a loading state. Just when the React Native content finishes to load in the background thread, we will be able to measure the layout of the React Native view content. And the size of the React root view will change from 0 to the right size. And this will produce like a jump on the native views, or what we call chunk. Deliver an user experience that is not great. You will probably see something like this. In the first render, you will probably see the loading state, and eventually when the React Native views are actually loaded, you will probably see that the native views actually jump. And this is actually not acceptable, because even if this is very fast, the user can still see it. So in order to deliver a better user experience for these kind of problems, we need a way to enable synchronous rendering and synchronous layout in React Native. This doesn't mean to switch React Native to be synchronous all the time. It actually means to change the current architecture of the framework in order to choose when we want to render or layout synchronously. Also, to improve the integration between React Native and the native platform, we would like to enable the computation of the layout on any thread. So, to implement these features, we will need to read and update the React shadow tree from different threads. This means that we will need these operations to be thread safe. And one way to achieve thread safety is to convert the React shadow tree to be immutable. What does it mean? Remember in the previous slide when we processed an update on the shadow thread, what we did is we updated one particular node of the shadow tree. In the new implementations, we are not doing that anymore. Every time that there is an update, what we're going to do, we are going to clone part of the React shadow tree, and we are going to create a new version of the React shadow tree. And we are going to process that update in the new version of the React shadow tree. And that will enable us to have thread safety in the React shadow tree. So as a result, we are working on a full refactor of the UI layer of React Native to make the framework thread safe and be able to enable these new features. Now I'm going to do a deep dive into what UI layer means. On the top of the UI layer, we have the React components. These are the components that we, as React Native developers, write in JavaScript. This can be a view, a text, or your custom component. These React components are managed by React and transformed into the virtual DOM. And in the context of React Native, we call this React Native Renderer. React will process the React virtual DOM, and for each update, it will send operations to the native side. Each of these operations are going to be processed on the native side to create the React shadow tree. Now, each of these operations are actually sent from JS to native through the bridge. The React Native bridge is a component that enables a two-way communication between JS and native. And this communication is 100% asynchronous, most of the time. The bridge, as Matt mentioned yesterday, is mostly written in C++ and is currently shared between different platforms. As we mentioned before, the virtual DOM is represented as the React shadow tree in the native side. So now you can see that we have one tree on JS and another tree in native. And this tree is controlled by the UI Manager module. The UI Manager module is another component that receives the commands from JavaScript. These commands can be create view, remove view, update props, etc. And using these commands, the UI Manager module creates or updates the React shadow tree in the native side. Once that the React shadow tree is updated, the UI Manager module calculates the layout of the shadow tree, updating the layout metrics for each of the nodes of the tree. So now we can see that one of the particular nodes has like the layout metrics. Using the result of this calculation, the UI Manager module updates the native UIs using the view managers. Here, each circle represents a different view manager. For example, you will have a text view manager, or your scroll view manager, or your custom view manager. Let's say that you implemented a map, you will have a map view manager. And each view manager is basically responsible for rendering views in the screen. So this is a summary of the UI layer of the current implementation of React Native. Let's see what we are changing. The first step of the refactor involved to change the implementation of the React Native renderer. We changed the API that communicates JS to native in order to enable immutability of the React shadow tree. As part of the refactor, we are also updating the communication between JS and native. This new bridge enables synchronous and asynchronous calls with multiple priorities. For example, now you will be able to execute high and low priority events synchronous and asynchronously. In other words, we are trying to make the bridge faster and lighter and to enable new features and improve performance. The UI Manager module, along with the shadow tree and the layout system, were also re-implemented from scratch in order to enable immutability of the React shadow tree. And these components were actually re-implemented in C++. This is allowing us to reuse more code between different platforms. What we are basically doing with this is like we are expanding the amount of code that we can share between iOS, Android, or any other platform. Before, it used to be only the bridge. Now we have the UI Manager module, all the management of the React shadow tree, and all the layout system. And we can do this because all this code is actually the same. It doesn't depend on the platform. So why not to share? The same way that you want to share your JavaScript code, we want to share our framework code. And finally, we are implementing some components to play better with this new architecture. This mostly includes components like text, view, scroll view, and so on. And the idea is just to integrate better with the C++ implementation of the UI Manager module. And you might be wondering, does it mean that if we are re-implementing our view managers, does it mean that you will have to re-implement your view managers? And the answer is no, because we are working on creating a new compatibility layer to reduce the amount of breaking changes. Look, Facebook has many apps written in JavaScript, many screens, I don't know, hundreds of thousands of components. I don't know the number. But we have hundreds of developers, and we cannot force each of the product teams to rewrite their code every time that we make a change in the framework. And the same thing with the open source community. We cannot force you. We always work on making incremental changes that move us forward in the direction that we want to be in the future. Again, just to summarize, with the new architecture, we will be able to enable synchronous rendering and the computation of the layout on any thread. And the bottom line for you is that this will deliver a better user experience in different parts of the framework. For example, you will have a better gesture handling, or like you will see that text input handling and the touch operations and some scrolling will feel smoother. This will also help integrate React Native better with the native platform. And of course, the React Native, we believe that React Native will feel faster as a whole. The entire platform will feel faster because of the new implementations of the bridge and the performance improvements that the React Native team is working on right now, and some of the features that we are including in this new re-architecture. Finally, I wanted to share with you the status of the project. This is a big project, and it was divided in three big milestones. The first milestone was to test this new architecture in production. The idea was to be able to validate the architecture, find blockers, and learn about all the pieces of the code that we will have to refactor in order to implement this new architecture. And as a result, we actually ran the new architecture in production. This has been running in some small screens of the Facebook app for iOS and Android. And since we didn't find any major performance or memory issues, we decided to move forward and start working on the second milestone. The second milestone is to extend the refactor to the entire framework. This means to enable the new architecture in some part of the frameworks that is not enabled yet. For example, the event system, animations, and in the implementation of complex components. As I mentioned before, we are also starting to reuse more code between iOS and Android. During the first milestone, we implemented the UI Manager module and Shadow tree in C++, and that was mostly tested in iOS. During the second milestone, we are actually integrating this inside Android. And the expected result of this milestone is to be able to do a full parity rollout of the new architecture. This means to be able to switch to the new architecture without experiencing any change in production. We are currently working on this. And finally, after the new architecture is fully rolled out into production, we will be able to start implementing new features on top of this, like enabling synchronous rendering, improving interoperability between native and React Native. Well, this is all I wanted to share for now. This is a very big project, and we are going to keep sharing the progress with the open source community. I know that this is a lot of information, and I'm going to be here during the afternoon, and there are other folks from Facebook as well. Kevin and Eli are here. So just come and talk to us and ask any questions. And you can also follow me on Twitter, and thank you for listening.